We are to the last section of this chapter already. And for the majority of this chapter, we've been talking about circles and angles and arcs and things inside of circles. But this kind of just, brings us back to what an equation of a circle will look like. In algebra, we talk pretty heavily about equations of different things. We talk about like a linear function, a function that is linear, L-I-N-E-A-R, there you go, a linear function, or like y equals x. That's what he will look like as an equation, and he'll just be a straight line like this. A quadratic function. You guys are all bored of me saying this over and over again, I'm sure. This guy's a parabola. You could do a cubic function. Things that are cubic, or y equals x cubed, will be things that look like this. You might have, like, let's say, an absolute value function. I have y equals absolute value of x, and that guy's going to look like a v. Okay. And I could go on forever about other functions. Let's do one more. We'll do square root function. This one is a square root function. Okay, and these are all ones that I drilled into your head last year in algebra. But he starts there and he goes on to the right forever and ever. So those are just different types of functions. That's not all of them that we learned, but that's probably the majority of the ones that I drilled into your head in algebra. This one is an equation of a circle now. So kind of add this to your toolbox of what these guys look like, and kind of the skeleton or the parent function. These are all called parent functions. Okay, the parent function for a circle looks like this. Circle this guy right here. He is the radius squared equals x minus h squared plus y minus k squared. Okay, so things that we need to know, or things that we have to have in order to write an equation of the circle. There's only two things. We need to know what the center is, and we need to know what the radius is. Okay, those are the two things that we need to know, and then we're done for finding the equation of the circle. The center of the circle is h comma k, and the radius of the circle, whatever that radius is, that goes into this spot. Okay, so writing this circle, or writing this equation, if you know what h and k are, you'd plop those numbers in there. So you'll have x minus some number squared plus y minus some number squared equals whatever the radius squared is. So these two things are embedded into the equation, and then you're done. Okay, now this equation comes from the distance formula. Okay, so remember him. We deal with him all the time. Distance equals the square root of x2 minus x1 squared, y2 minus y1 squared. The only thing that they've done here is they're talking about distance, and instead of distance, they're saying, let's call it the radius instead. And let's call our x2 x and our x1 h. And let's call our y2 y, and let's call our y1 k. And then, to get it from r to r squared, they square both sides to get rid of this square root. Okay, so we just have on this right side just the stuff that was underneath of the square root. X minus h squared, y minus k squared equals r squared. Okay, and so it comes from the distance formula. That's where this equations of circles comes from. And also distance formula, I always think back to the Pythagorean theorem. Okay, so Pythagorean theorem, this is like your a squared, this is like your b squared, and then d is really your c squared, and you take the square root to get just d. Okay, so a squared plus b squared equals c squared. Standard form of a circle, x minus h, y minus k equals r squared. They want us to write the equation of each circle, so they give us exactly what we need. We need the center, we need the radius, and then we just need to write the equation. Okay, so it goes, I'm gonna put the radius over here. Okay, I'll put the radius on the right. So I need x minus h squared plus y minus k squared equals the radius squared. Okay, and so these numbers just go in here. One is the x coordinate. Okay, but the thing that you have to remember when you plug them in, if it's a positive one inside the equation, it's going to flip the sign. So it will actually be negative. That's why it's x minus h, y minus k. Now, what do you do if it's already a negative? Okay, this will be y plus 8 because it will be y minus a negative 8. Okay, basically. And then this guy is the radius squared. So since they give it to me as a number already, I'm going to say 7 squared. Let's go ahead and write it as 49. Okay, so this is my solution. This is the answer to my equation of my circle. Okay, now the circle that's graphed at the right. Okay, the two things that we need are the center, and then we need the radius, and then we need to write the equation. Okay, so the center here of the circle is at the point 0, 4. The radius of the circle, they don't tell us, but we can just look. I can either count from here to here, or I can count up, or I can count to the left, or I can count down. Any of those are going to be, is it going by ones? That's what I'm trying to look at. Yes, it's going by ones. So that will just be a radius of 3, okay? So the radius is going to be 3, and then I just need to write the equation, okay? So I've got x minus h squared plus y minus k squared equals the radius squared, okay? All right, so x minus h will be x minus 0, y minus k will be y minus 4, and then the radius squared would be 9. Okay, now the only other thing that I'm going to do to this is, rather than writing it this way, x minus 0 squared, I might as well just write that as x squared. So sometimes you'll see it written like that if the other piece of it is 0. If your h or k value is 0, they'll just write it as x squared or y squared. Okay, plus y minus 4 squared equals 9. Okay, and we just leave it like that. Do not think that you have to like FOIL that thing out or anything. That's the standard form of the equation. They want you to leave it as those two pieces squared, and those two pieces squared. Okay. All right, next, example 2. Write the equation of the circle. So the two things that I need are the center, and I need the radius. Okay, now they give me the center here, but they do not give me the radius. When it says passes through the point -6, 7, here's what it means. Okay. I'm going to draw this out for you. You don't necessarily have to always draw this out, but here's kind of what this means. The center is at -2, 4. That's where my center is. And it passes through the point -6, 7, which is going to be up here somewhere. Okay, so basically I have my circle that's going like this, and the radius is going to be this distance here. Okay, so when it says it passes through the point -6, 7, that means that that's on the outside of the circle. And so what I need to do to find the radius is I need to do the distance between those two using the distance formula. Okay, so I'm going to do my distance formula off to the side over here. Okay, and this is something that you should kind of have drilled in your brain. Okay, if you need to cheat and look at this, you can always go up here to this distance formula: x2 minus x1 squared, y2 minus y1 squared. Okay, that's what we're doing for distance formula down here. And the 2 points that we're using are these guys. Okay, -2, 4, and -6, 7. Okay, so I need my x2, my second x coordinate, -6 minus -2, which will be -6 plus 2. Okay, then I do 7 minus 4. That's the other part of it. Okay, so I have -6 plus 2. This guy is going to be -4, and -4 squared is +16. Okay, they always turn to positives. 7 minus 4 is 3. 3 squared is 9. So I have 16 plus 9. Oh, beautiful. The square root of 25, which is just 5. So I have my radius is 5. Wonderful. Okay, these two things are the things that I need, the center and the radius. So now I just go through and I make my x minus h, y minus k equals the radius squared. Okay, so x minus the h is going to change that to +2. Y minus k is going to change that to, or make that y minus 4. And the radius squared will be 25. Okay, so that's what I want for my equation. All right, so just a little bit more work to find the radius, but just use that distance formula. Okay, same thing here for part B, the circle graphed at the right. So we need the center and we need the radius. Okay, so center here is at 3, -2. Okay, and the radius, it would be really nice if I could just count all the way out there, you know, like from here to here, but this is not touching at an exact even place. So what they're giving me is this 0.51 out here, which is also a radius. Okay, that's going to be the same length or the same distance, and I just need to find that. Okay, using that distance formula again. Okay, so let's do that real quick. Distance. I need x2 minus x1. Let's go ahead and say x2 is going to be 5. So let's do 5 minus 3 and 1 minus a -2, or 1 plus 2. Okay, 5 minus 3 is 2. 2 squared is 4. Okay, plus 1 minus a -2, or 1 plus 2 is 3. 3 squared is 9. Okay, now 4 plus 9 is 13, and this guy will be the square root of 13. Here's what I don't want you to do. I don't want you to actually figure out what that is as a decimal. Okay, and here's why. we're going to write the square root of 13 as my radius, because when we do our formula for our circle, okay, this guy is the radius squared, okay? So let's think about it. If you take the square root of 13 and you square it, what's going to happen is that's just going to go away, and this number will just be 13 here, okay? So if I convert that to a decimal, then if I square that decimal, then it will probably end up in another decimal because you would have rounded to start with, and it's just going to end up being a mess. So when you square this number for the radius, it will actually end up just popping out of that piece, you know, kind of like up here. We had the square root of 25, came out really nicely to be 5, but when we squared it again, look, it was the same number that was inside of our square root, right? Okay, so don't, if it doesn't come out nicely, don't ever convert it to a decimal because it's just going to end up popping back out again, okay? X minus 3 is what will go inside of here, and y plus 2 will go inside of there, okay? So that's going to be my equation, right? I'm kind of going through this fast, but hopefully this is pretty basic. Let's go to the back side. Now they're going to give it opposite, okay? So they're giving you this equation, and they say graph the thing, okay? So we need to know the center, we need to know the radius, okay? So my center is going to be determined by this point right here and this point right here, okay? Now remember that you use the opposite sign. So if this says -4, it's going to be the point +4, comma, this says +1, so I'm going to use -1, okay? So the opposite sign, the radius is the square root of this, okay? Square root of 9 is 3, okay? So to graph him, I'm going to start at 4, -1, dot right there. And then from this point, I'm going to go over to the right 3, 1, 2, 3, put a dot. I'm going to go from that point up 3, put a dot. I'm going to go to the left 3, put a dot, and I'm going to go down 3, put a dot. And then my blue dots, I'm just going to connect all those and put it, kind of looks like a circle. There we go, not too bad. Okay, so that's what my circle's going to look like. Center, radius, circle drawn, done. Okay, all right. 2 more. Example 4, 3 tornado sirens. They've graphed these tornado sirens. Are placed strategically in a circle around a town so they can be heard by all. Write the equation of the circle on which they are placed if the coordinates of the sirens are at A is at -8, 3. So -8, comma 3. I'm going to mark that in here. B, they've marked at -4, comma 7. And C is at -4, comma -1. Okay, and then the way that they've graphed this circle is that BC is the diameter of the circle, okay, and A lives kind of equidistant between B and C, okay, so he's kind of making a right triangle there. The center of my circle is going to be this dot, okay, so we just need to determine the coordinates of that center. Where is that center located, okay? Well, I know that he has to be over at -4 because he's on this line with -4, 7 and -4, 1. So the center is going to be at -4 something, right? And if he has to be on line this direction with A, and A is at -8, 3, then this point has to be at 3, okay? Or you can just look at kind of where these crosshairs are. This is the y-axis, this is the x-axis, right? So he is literally at -1, 2, 3, 4, and up 3, okay? So you can determine it that way also. So I have my center, and then I need to know my radius, okay? There's 2 things that I need. Right, from this dot going to the outside of the circle, it is 1, 2, 3, 4 units. Okay, I could count 4 units down or 4 units to the right or 4 units up, but my radius is going to be 4, so I just need to write my equation. Okay, so x minus a -4 or x plus 4, this will be y minus 3, and the radius, if I square him, he will be 16. This is my equation. Okay. All right, last one, intersection with circles. So it says find the points of intersection between this circle, which is x squared plus y squared equals 4. Okay. Now another way of writing x squared plus y squared equals 4 is x minus 0 squared plus y minus 0 squared equals 4. Okay. This is a circle whose center is at 0, 0, and whose radius isn't 4. His radius will be 2 because I take the square root of 4. Okay, so I have a circle with center at 0, 0, and a radius of 2. So 2, 2, 2, 2. This is what my circle will look like. This tiny guy right here. okay? And I want to know, find the points of intersection between him, this guy is a circle, and the line y equals x, okay? We talked about y equals x already in this section at the top here. Y equals x is a linear function that's going to go straight at a 45-degree angle through 0. So basically, this linear function, another way of writing this is y equals x plus 0, or y equals mx plus b. This is y equals 1x plus 0. So I would start at 0, and from there I would go up 1 over 1, up 1 over 1, up 1 over 1, or down 1 to the left 1, and this is my my line there, okay? So I'm trying to find where those guys are going to intersect each other, and really they're going to intersect at 2 places, okay? This guy right here and this guy right here, and I have to find those, okay? So if you remember from Algebra 2, we did like substitution and elimination to find where 2 lines were intersecting each other, right? So maybe I had 2 lines, and I would take those 2 equations and I would either try to eliminate something, or I would try to plug one into the other one to find where this point lived, okay? That's exactly what I'm going to do here. I have the 2 equations, x squared plus y squared equals 4, and then I have y equals x, okay? So what I'm going to do, this one I can't really do elimination with. I can't like stack them up on top of each other because one of them is squared and one of them is not. But what I can do is I can substitute in stuff. I know that y is equal to x, okay? So I can take this x and I can plug him in where the y is, right? If y equals x, I can say x squared plus this y is now the same thing as x, so I have another x squared equals 4, right? So I have x squared plus x squared equals 4. Now, when you add an x squared and x squared together, it's not x to the 4th power. That would be multiplying. This will give me 2x squareds. Okay, and then to solve for x, I would divide by 2. So x squared would be 2. Okay? And to get x by itself, I would take the square root. So x will be the square root of 2. Now, if you remember from algebra, when we put the square root in there, it will be positive square root of 2 and negative square root of 2. Okay, so that's where this comes into play, the 2 answers. This point right here is going to be positive square root of 2 comma something, and this guy will be negative square root of 2 comma something. Okay, that's those 2 points. So that's where I get the 2 answers, is the plus and the minus. Okay, and then I have to figure out what the y coordinate is. Okay, well, I can either go back in and I can plug x in here, or I can plug x in here. Well, this one just says y equals x. So if x is square root of 2, the y is also going to be square root of 2. Like if I plug square root of 2 in for x, y will be that, right? This guy, if x is negative square root of 2, this will also be negative square root of 2, okay? So the 2 places where they're going to cross each other are square root of 2 comma square root of 2 and negative square root of 2 comma negative square root of 2, okay? You could have given that as a decimal, and that's okay, but square root of 2 is a more exact answer, and it's probably less writing if you don't want to write out all your decimals. So these are going to be the 2 places where they're going to cross each other. Okay, so that was just kind of a review over substitution, but this was with a circle and a line instead of 2 lines crossing each other like we did in algebra. Okay.